Welcome to the Deep Dive. We take fascinating sources, sometimes seemingly unrelated ones, and pull out the absolute key insights for you. And today we're doing something pretty unique, I think. We're going to explore this really surprising link between a concept called metaphorical placebo pipes and the actual intricate ways your brain handles timing and coordination.
It sounds a bit strange at first, doesn't it? Placebo pipes.
Right, it does. But okay,
Yeah.
let's try and unpack this because the connection is genuinely fascinating. We're basically pulling from two quite different areas for this deep dive. On one hand, we've got bits from something called a Meta-AI Task Force Directive. Sounds very official. And that's where these placebo pipes pop up in the context of like how teams work together dynamically. And then on the other side, we have some solid neuroscientific research, really detailed stuff looking at how placebo effects physically change the brain. Real measurable changes.
Yeah, and that's where the magic happens, bridging those two. It seems like totally different worlds, team dynamics, metaphors, and hard neuroscience.
Exactly. But you'll see as we get into it, there's this amazing overlap. It actually gives us, and you listening, a really fresh way to understand some fundamental brain science without needing a PhD.
That's absolutely the goal today. Our mission really is to distill how your brain pulls off this incredibly precise timing and coordination. And crucially, how even subtle things, especially your own expectations, can really profoundly tweak these processes right down at the neural level. Think of this as your shortcut, a way to get those aha moments about basic neuroscience, but, in an engaging way. No getting lost in jargon, hopefully.
Yeah, we want to walk away feeling like you get how your brain manages time and action and maybe appreciate just how much your own mindset shapes that.
Exactly, the power of internal narrative.
Okay, so let's start with these mysterious placebo pipes. Our first source, this Meta-AI directive, throws us right in. It talks about Kick La Metta. Kind of cool name.
Yeah. Navigating these meta-artificial intelligence tasks. Big words. But basically, it's about teamwork in complex, fast-moving situations. And it stresses using a meta-communicative style. So what's meta-communication? It's not the actual work, right? Not the coding or the building.
No, exactly. It's the communication about the work, or maybe around the work. It's how you coordinate the process.
Okay, give me an example. Like if a team's building something complex.
Right. So say they're building an AI model, talking about the specific algorithms. That's direct communication. Meta-communication is discussing how you'll integrate them. Or clarifying the timeline, checking everyone's understanding, figuring out who does what by when, dealing with roadblocks, even just setting a kind of rhythm for the team.
Okay. So it's the stuff that makes the actual work possible and smooth, even if it doesn't feel like you're directly coding in that moment. It's about getting everyone aligned.
Precisely. Aligning expectations, building that shared mental model of how things should unfold over time. Temporal alignment, basically.
Temporal alignment. Got it. And this is where the placebo pipes come in.
Yes. Within this meta-communication idea, the directive introduces placebo pipes. And it's crucial to understand these aren't real.
Right, not actual pipes.
No. They're described as metaphorical placeholders, meta-communicative tools. And their specific job in these dynamic teams is to influence timing and coordination. The idea is they help teams align temporally, get everyone's internal clocks, their expectations about milestones and transitions all synchronized.
How would that work in practice? Like, do you say, okay, team, activating the synergy pipe?
Maybe not quite like that, but you might introduce a concept like a sprint alignment pipe for a project phase. And just by acknowledging it, by the team collectively sort of buying into its function, they implicitly adjust their pacing, they synchronize better. It's an intangible agreement, a shared mental tool that uses expectation to improve real-world timing.
Okay, a shared mental tool powered by expectation. Now I'm starting to see the bridge. Because you're sitting there listening thinking, teams, AI, pipes, what about my brain? And this is where it clicks.
Right. Our other sources, the neuroscience ones, make this direct link. They show how this whole placebo pipe metaphor maps surprisingly well onto the actual science of placebo effects in the brain.
Exactly. We know placebos work, right? Believing a sugar pill will help can cause real, measurable physiological changes.
Yeah, it's wild.
And crucially, those changes happen in the very brain networks that handle timing, coordination, and expectation. The same stuff the metaphorical pipes are meant to influence in a team.
So the pipes are fake, but the effect they represent, expectation influencing timing, is real in the brain.
Precisely. Neuroscience gives us the substrate model, the actual physical machinery. It shows how these sort of meta-level influences, your beliefs, your expectations, the context, genuinely affect the brain networks governing timing. It's
Right.
not just a neat parallel, it shows us how these things work. Which leads us to the big question.
Which is?
How does expectation, this core part of the placebo effect, physically change how our brains coordinate? How does a belief literally alter timing circuits?
Okay, yeah. That is the question. And for anyone listening who's new to neuroscience, this is huge, right? Seeing how your own thoughts can impact your brain's basic functions.
Absolutely. It's a powerful way in.
All right, so if expectation is the key, where in the brain does this start? We need to talk about the command center, don't we? The prefrontal cortex.
Definitely. The front office.
Yeah, I always picture it like the brain's CEO.
Uh,
Or maybe a conductor leading a massive orchestra. It's right there at the front, behind your forehead.
mm-hmm. And it handles all the high-level stuff, planning, decisions, controlling impulses, even personality to some extent.
And for today, we're zooming in on two specific parts, right? The DLPFC and the vmPFC. Lots of letters.
Yes. Let's break them down. DLPFC is the dorsolateral prefrontal cortex. Think of this one as your strategic planner, your task manager. It's big on cognitive control, managing thoughts, focusing attention, stopping distractions. When you resist checking your phone while working, that's your DLPFC working hard.
Okay, the impulse controller.
Exactly. And crucially for us, it's heavily involved in temporal organization. Sequencing events, understanding time, planning actions over a duration. Keeping you on schedule, basically.
Got it. DLPFC, planning and timing control. What about the other one, the vmPFC?
Ventromedial prefrontal cortex. This one is more like the brain's expectation manager, or maybe its value assessor. It deals a lot with emotions, weighing potential outcomes, making decisions based on rewards or risks, and absolutely key here, expectation and reward prediction.
So when you expect something good to happen.
Your vmPFC lights up. Like believing a treatment will work or expecting a project to succeed. It assesses the value of that expectation, and that shapes your actions and even your sense of time.
So DLPFC is how you do things over time. vmPFC is kind of why, based on what you expect.
That's a really good way to put it. One controls the execution, the other manages the motivation and anticipated value linked to time.
Okay, so how do placebos or expectations actually affect these CEO regions?
Well, this is where the neuroscience gets really cool. When you expect a positive outcome, like from a placebo, we see direct changes in these areas. For the DLPFC, we often see increased engagement. It gets more active. And importantly, its connectivity improves. It communicates better with other brain areas.
So the CEO gets more focused, more efficient.
Exactly. Better at organizing things temporally. And for the vmPFC, its activity gets modulated specifically around reward and expectation signals. And this directly influences how time is processed.
It's not just general brain boost then. It's specific to timing.
Very specific. If you expect to do something faster or experience something at a certain time, the vmPFC helps shape that reality neurologically. Your brain is literally prepping its timing mechanisms based on your belief.
Wow, okay. But these areas, the DLPFC and vmPFC, they don't work alone, right? You said they influence other parts?
Absolutely critical point. They're conductors, remember? They
Right.
direct the orchestra. They exert top-down control, modulating downstream network.
Downstream, like.
Specifically, our sources point to pathways involving the brainstem and the cerebellum. And these are fundamental for sensorimotor processing, handling senses, controlling movement, and especially precise timing.
Right. So the CEO sends memos down the chain of command to the departments that actually handle the moment-to-moment timing and action.
That's a perfect analogy. Which leads us to the next obvious question.
How does that top-down control actually work? How does expectation ripple down to fine-tune timing at these deeper levels?
Great question. It's all about networks. Brain regions talk to each other constantly. And placebo effects, driven by expectation, don't just flick a switch in one area. They change the conversation between areas. They alter functional connectivity.
Functional connectivity,
Right.
meaning how well different parts synchronize their activity, how strong the connection is.
Exactly, how well they're talking to each other. And the placebo effect modulates the connections between the prefrontal cortex and some key timing partners.
Okay, who are these partners?
Well, one major one is the periaqueductal gray, the PEG. It's deep in the brainstem.
PAG. Okay. What's its role in timing?
It's involved in a lot, including pain, but crucially for us, it integrates motor and autonomic timing signals. Think of it like a hub where signals about movement timing meet signals about your body's internal rhythms, heart rate, breathing, that sort of thing.
So it brings different kinds of timing info together.
Right. And placebo effects enhance its functional connectivity with the prefrontal cortex, especially the vmPFC. This means the high-level expectations from the front office can better influence these fundamental timing signals. Smoother, more coordinated responses follow.
Okay, so better communication between the expectation center and this timing integration hub. Makes sense. What else connects?
The cerebellum. Hugely important.
Ah, the little brain at the back.
That's the one. Don't let the name fool you. It's incredibly sophisticated. The cerebellum, especially its Purkinje cells, is the master of precise motor timing and error correction.
Error correction. How so?
It's constantly comparing your intended movement with your actual movement in real time. And it makes these tiny, lightning-fast adjustments to keep everything smooth, accurate, and perfectly timed.
Like when you catch a ball or play music.
Exactly, or even just speak fluidly. The cerebellum is fine-tuning everything, making subtle adjustments to keep you on beat, moment by moment.
Okay, so how does expectation influence the connection between the prefrontal cortex and this master fine-tuner, the cerebellum?
That connection also gets modulated. The changed connectivity, this altered conversation between the prefrontal areas in both the pay and the cerebellum, is what allows for flexible updating of temporal expectations. It means your brain isn't just reacting. It's actively predicting and adjusting its timing based on what it expects. It's adaptive.
So back to the placebo pipes.
Right. Just like the metaphorical pipes align a team by shaping shared expectations of rhythm, your brain is doing its own internal alignment. It's constantly tweaking its timing mechanisms based on your internal models and beliefs. It's an internal synchronizer.
That's really something. We're talking big networks, prefrontal, brainstem, cerebellum. But what about the absolute basics? The neurons, the connections between them. Does expectation reach that deep?
It absolutely does. And this is where animal models have given us incredible insights into the cellular and synaptic mechanisms, the real nuts and bolts.
Synaptic, like the synapses, the connections?
Exactly. Two key things seem to happen. Changes in synaptic plasticity and changes in feed-forward inhibition.
Okay, break those down for me. Synaptic plasticity.
Think of synapses as dynamic bridges between neurons. Plasticity is the brain's ability to change the strength of these bridges, make them stronger, weaker, build new ones, remove old ones based on experience and activity. It's the core of all learning and memory.
So when you learn something, your synapses change.
Fundamentally, yes, and placebo conditioning research shows it increases this plasticity in specific relevant circuits. The connections become more adaptable, more easily rewired or strengthened by expectation.
Whoa. So my belief can make my brain's circuits literally more moldable, more receptive to operating on the timing I expect.
That's a perfect way to phrase it, yes. More trainable by your expectations.
Okay. And the other thing, feed-forward inhibition. Sounds technical.
It is a bit, but think of it like a precision braking system for neural signals. It helps fine-tune communication by suppressing excessive or noisy activity, keeping signals clear.
So like noise cancellation.
Sort of, yeah. Ensuring precision. Now, what's fascinating is that placebo conditioning seems to slightly impair or reduce this inhibition in certain targeted circuits.
Wait, impairing it? Reducing the brakes? Isn't that bad?
Not necessarily in this context. By slightly easing off the brakes in specific pathways, it allows the important signals, the ones related to the timing and coordination you expect to become stronger, more excitable, they get through more effectively.
Ah, I see. So less braking on the important signals for timing.
Exactly. So you combine these two effects. Increased plasticity making circuits more adaptable, and reduced inhibition making the key timing signals more potent. And where does this happen? Specifically in those circuits linking the prefrontal cortex to the cerebellum and brainstem. The very pathway is critical for motor timing and coordination.
So it all connects back.
It really does. The net result is enhanced excitability and temporal precision in those crucial circuits. We're seeing a physical cellular mechanism where expectation subtly but powerfully alters connections and signaling, priming the brain for precise timing.
Mind.
Yeah.
Blown. Seriously. It's not just a feeling. It's actual wiring changes.
It's mind-body connection at the synaptic level.
Okay. Let's talk rhythm then. Because timing isn't just hitting specific points. It's about flow, right? Does the brain have like a rhythm section keeping everything groovy?
It absolutely does. And that's where neural oscillations or brain waves come in.
Brain waves, alpha, beta, theta, that stuff.
Precisely. They're not just random electrical noise. They are large-scale, rhythmic patterns of activity constantly flowing through your brain. Different frequency bands, alpha, beta, theta, are linked to different cognitive states and functions. Think of them as the brain's internal metronome. Or maybe multiple drummers laying down different beats that help synchronize the entire neural orchestra.
And they're involved in timing.
Critically, they govern temporal sequencing, how attention is coordinated across different areas, how networks communicate effectively. They provide the underlying rhythmic scaffold for coordinating everything cognitive and motor over time.
Like a conductor's baton for the whole brain.
Very much like that. Setting the tempo, ensuring everyone plays together, information flows efficiently, actions happen in the right sequence. They create the temporal framework.
Okay. So if brainwaves set the rhythm, how does expectation, the placebo effect, influence them?
This is another really elegant part of the story. Placebo contexts, where positive expectation is high, directly modulate these oscillations. We see increased oscillatory power, particularly in those alpha, beta, and theta bands, specifically in frontocentral regions.
Frontocentral, so near the prefrontal cortex again.
Exactly, right where those high-level control centers are. And this increased power isn't random. It directly tunes the timing mechanisms.
So the brain's metronome gets louder, clearer, more stable.
All of the above. The conductor's beat becomes stronger, making it easier for all the different brain sections to synchronize, to stay in perfect temporal alignment.
And this happens just from expecting something.
It seems so. Something as seemingly subtle as belief can literally change the rhythm and power of your brain activity. It influences the very temporal scaffolding that coordination relies on. It's actively tuning your internal clock based on anticipation.
That's incredible. Top-down mental states shaping bottom-up neural rhythms.
Beautifully put.
Okay, we've hit the command center, the networks, the cellular level, the brain's rhythm. But what about interacting with other people? Teams need to coordinate together. How does understanding others' intentions mentalizing fit with timing?
Ah, yes. Because coordination is often social, right? This brings us to the temporoparietal junction, the TPJ.
TPJ. Where is that and what does it do?
It's where the temporal lobe and parietal lobe meet, sort of above and behind your ear, and it's a key hub for mentalizing, or theory of mind.
Theory of mind. That's understanding what other people are thinking, their intentions, beliefs.
Precisely. It's how you infer others' mental states, anticipate their actions, understand why they do things. Absolutely vital for smooth social interaction, communication, and, yes, social timing coordination.
Right, you can't coordinate if you can't anticipate the other person's rhythm or intention.
Exactly. Imagine trying to dance with someone without any sense of their next move. Chaos.
So how does expectation link our own timing control with this mentalizing hub, the TPJ?
Here's another fascinating connectivity finding from our sources. During placebo-induced expectation, like expecting a treatment involving social interaction to work well, the functional connectivity increases between the DLPFC and the TPJ.
DLPFC, our own timing and control CEO, starts talking more effectively with the TPJ, the Understand Others' Intentions department.
You got it. Better communication between internal control and social understanding.
What's the significance of that?
It reflects higher order mentalizing being integrated with the timing of your own adaptive responses, especially in a social or team context. Your brain isn't just optimizing its own internal schedule, it's actively tuning that schedule based on what it anticipates from others. It's synchronizing your internal clock with the perceived intentions and rhythms of the group.
So it's like your brain is preparing to coordinate with others based on the expectation that the collaboration will go well or follow a certain pattern.
Precisely. It's the neural basis for predictive adaptive team behavior. You're not just reacting, you're anticipating and flowing with the social context, driven by expectation.
Wow. And that loops right back to the metaphorical placebo pipes helping teams synchronize. It's like our brains have these built-in expectation-driven mechanisms to do just that neurologically.
It really shows the brain's incredible capacity for complex social and temporal coordination, all orchestrated internally based on belief and anticipation.
Okay. This has been a journey, from AI team directives to brainwaves and synapses. For someone maybe new to all this, let's try and synthesize it. What's the big picture? How does expectation actually orchestrate brain coordination?
Let's tie it all together. That placebo pipes metaphor, while abstract, really helps us grasp a concrete reality. Your brain achieves incredibly sophisticated timing and coordination, and your expectations are a powerful active ingredient in that process. The core idea: Your brain is dynamic, constantly coordinating and updating, and your beliefs physically modulate how it does that.
And it starts with the prefrontal cortex.
Yes, the DLPFC and vmPFC, they act as the directors, setting the goals for temporal precision, driven by expectation.
And they conduct the orchestra through multiple mechanisms.
Exactly. Multiple layers. First, functional connectivity. They strengthen communication with key partners. The PAG in the brainstem for integrating timing signals, the cerebellum for fine-tuning movement, and the TPJ for social timing and understanding others. Better talk between departments.
Okay, connectivity is layer 1.
Layer 2 is the microlevel. Synaptic plasticity increases, making circuits more adaptable, and feed-forward inhibition is selectively reduced, making key timing signals stronger. The actual wiring and signaling get optimized.
Wiring gets primed. Got it.
And layer 3.
Layer 3 is the overall rhythm. Neural oscillations, alpha, beta, theta waves get boosted in power and stability, especially in those frontocentral areas. The brain's internal metronome gets clearer and stronger.
Okay, so connectivity, synaptic changes, and brain rhythms, all working together, orchestrated by the prefrontal cortex based on expectation.
You've nailed it.
So what's the ultimate payoff, the so what for us day to day? The so what is huge. This intricate coordination enables flexible temporal prediction and execution. Your brain isn't just reacting, it's anticipating, adjusting on the fly, executing actions with precision, even in complex, changing situations. That's what you need for playing sports, for performing complex skills, and absolutely for coordinating effectively within a team, collaborating, communicating seamlessly. It's the neural basis for flow and synchrony.
So this neuroscience gives us a real physical model for how even abstract ideas about timing, like those placebo pipes, actually work by tapping into these fundamental brain networks.
Precisely. It's a tangible substrate model. It shows your expectations aren't just thoughts, they are physical modulators of your brain's core timing machinery, shaping how you navigate the world and interact with others. Understanding this gives you a sense of agency over your own neural landscape.
Wow. So we've gone from metaphor to molecule, really. From team dynamics to synaptic changes, all linked by the power of expectation. Listeners, you've just gotten a really deep look at how your own mind can literally retime and rewire your brain for better coordination.
And that leaves us with a final thought, something for you to really chew on. If our brain's timing and coordination are so profoundly shaped by internal expectations, by these metaphorical pipes fueled by belief, what does that imply about the hidden power of our mindset in everything we do?
Like learning a skill or working on a team.
Exactly. How much of our daily rhythm, our ability to coordinate smoothly, is actually an unconscious act of internal placebo piping? Our beliefs subtly shaping our neural machinery for success or failure?
That's a big question.
It is, and it raises another. Knowing this, how might we consciously use this understanding? How can we leverage the power of expectation now that we see its physical basis to enhance our own learning, our collaboration, our performance by tapping into that incredible internal capacity for alignment? The potential there is, well, it's quite remarkable to consider.